Let's get started again. Hey, George, it says host disabled attendee screen sharing for some reason.
Yeah, I understand. Hold on, give me a sec. Okay, you should be good to go.
Cool. All right, cool. So today I'm going to introduce a little idea about what's called IntraTask checkpointing and resumable task execution on Flyte. As we all know, Flyte itself is designed to be a checkpointing system already. And it's working as a checkpointing system, but the checkpoint happens at the task boundary currently. But a lot of use cases on Flyte mandate a longer running tasks, such as, some use cases such as ML model training, or even, some other type of long running processes to be completely, inside one single task. So the introduction, this idea is to further complete this direction of feature to make it possible that the task can be paused or interrupted, but later on it can be resumed, so that the user don't lose any partial progresses when they execute certain tasks. So as you can imagine, this is a very common feature inside the ML community. Checkpointing has been used in all of the, has been equipped with in all of the ML frameworks. PyTorch, TensorFlow, Keras, all of them have this checkpoint support to allow them to store that partial progress, and then in the case of computer crashes, or even they just want to preserve the current best model, they will use this checkpoint to achieve that purpose. So, but beyond that, you can imagine that this checkpointing thing can also help us do some, it can also help us do some kind of cost saving when we leverage those interruptible instances on each of the in each of the cloud providers. So you can imagine, like, for example, AWS Spot instance is something that it doesn't guarantee the completion of the execution, but in exchange with for that, it provides a very low hourly rate. So leveraging the checkpointing in this case, IntraTask checkpointing in this case, will allow you to save your partial progress, and when you are running things on interruptible instances, which will create a lot of cost saving opportunities. So this is a feature. This is a ticket I created inside Flyte, and then basically what's the important thing here is that it links to this design doc, which is public now, I believe. If some people, if any of you cannot access this, please let me know, but I believe this is already public. Okay, so this project is at the beginning phase, where we are still doing the design. So please feel free to give feedback and on this doc. So let's briefly go through this document. So as we just said, the goal of this project is to focus on providing the explicit IntraTask checkpoint support What do I mean by explicit checkpoint? It means that the user needs to specify explicitly what variables or states they want to checkpoint. And then, and also with this current version, we want to first focus on checkpoint that can be resumed from the same node execution only. So for example, you can imagine if I have a checkpoint, some people might want to say, hey, in the later, in different workflow execution, I want to, jumpstart with a checkpoint I saved previously in another workflow execution. That might be a valid use case, but that might not be the best target to focus on at the very beginning. So we will decide whether we want to defer this, or maybe we will have another project for this purpose. But so what I'm trying to say is this project currently focuses only on checkpoints that can be resumed from within the same node execution. And as we said, also we don't want to automatically checkpoint the entire program state. We want the user to specify what they want to checkpoint and what they want to save, and we only save those things to the cloud or persist to somewhere. And then the user should be able to just figure out and reconstruct the state by looking at the content of these explicitly checkpointed variables. So the background and motivation are just very intuitive, and we just discussed about it, like the ML use cases, cost saving opportunities, all those. So currently, there's a keyword in Flyte called interruptible. I'm not sure if it's available in the open source version, but currently interruptible means that this task can be scheduled onto a spot, say an interruptible instance, like spot instance. However, when the execution is interrupted, it will not be able to jumpstart from the partial progress it has made. Instead, it will restart this execution from the very beginning. But it just, so how do we guarantee that the execution will finish? So in this case, the interrupted execution in its next execution, it will be scheduled onto a normal instance. So this is slightly, so you can imagine that this is a different use case. It want to try to see if it can complete within the time that the spot instance is alive. If not, it will use the higher cost instance to ensure the completion of the execution. So that is a little bit different from what we want to propose today. We want to be able to keep using spot instance, and we make even if we can just make a little bit of progress every time, eventually we will get there with our partial progress being checkpoint every time. Yeah, so I don't want to go to too much details on these design, but I just want to talk briefly that how do you, so there are several components you need to implement inside across the entire Flyte architecture to make this happen. So the most important components include data catalog, Flyte propeller, Flyte kit, and Copilot. And these four, so I draw some of the data flow and timing diagram for different cases. I have a data flow and a timing diagram for the checkpointing, which is saving, like the persisting path, and also a different set, data flow and timing diagram for the resuming path. So let's take a look at what actually happens. Maybe in this. Let me zoom in a little bit. Oops. Okay, cool. So as you can see here that, oh, sorry, my laptop is lagging a little bit. Okay, so okay, let's first look at the data flow graph. So you can see that these are the interaction between all these different components inside Flyte. So Propeller will interact with data catalog to register the execution ID, which serves as the signature of that checkpoint to data catalog. And then also the value of that key will corresponding to that key will be the checkpoint data reference. And also Propeller will also provide Copilot and Flyte the actual data reference that these two components should use to actually download or upload the data to or download the data from. And Flyte will write the actual data. User will actually trigger that write of the data through Flyte to a local value. And the Copilot will read from that local value and then upload the data to S3 or any remote cloud storage. So this is just basically, it's very intuitive and how this should work. And then inside from the timing perspective, what we can see in this graph is that, so basically, these several components work together. The Copilot is basically responsible for uploading the data continuously. So we want to do a continuous checkpointing to make sure that we don't miss how to say, we don't, when we want to, sorry, let me talk about the user side first. So when the Flyte, after the Flyte launch the user function can start to save data locally to a local value through Flyte. But then after the user finish a round and it has a consistent snapshot of the state they want to preserve, the user need to want to call the persist function inside Flyte. And then the Flyte will then tell Copilot to upload the current snapshot of the data. And then at the same time, the user can still write to can keep making progress and save other things, but this time it will be saved to a different buffer. And then the next time when the Copilot finish uploading the first batch of data, it will look at the second buffer and then try to upload that second the data from that second buffer. So this kind of create this allow user to specify, hey, I have done writing this batch of data. You can snapshot it and upload it. I'm fine with it. And Copilot can do this continuous uploading to make sure that we always keep a good partial progress of the user function. And then at the time where the interrupt from the cloud provider comes in, if the data is not written, has not been persisted, then we won't get the partial snapshot of that last batch of data. So we by using this mechanism, we ensure that this this uploaded snapshot is consistent within itself. So yeah, so this is the checkpointing diagram, and then yeah, sorry, I know this is a little bit. There are a lot of things going on in this diagram, so please feel free to take a look yourself, and please leave feedback, and we can discuss more in details. And resuming is simpler. It's basically you know, just the copilot will just at the very beginning, after the copilot get the data URL by you know, when it derived the data URL from the execution ID and all those, it will just try to go up to the cloud provider, the cloud storage, and fetch that data and put it into a local volume. And Flyte will also know that the local data reference of that local volume inside that local volume, and it can pass that local reference to the user function or things like that. So this create an abstraction, and also the reason why we want to use Copilot is that we don't want to interfere. We don't want to take a lot of resource from the user function execution. We want this to be resource-wise separated. The upload of the data and user function to be resource-wise separated. Is there any questions so far? Okay. So we have decided to divide this project into several phases. The V0 of this project is a very simple implementation to support the SageMaker training job task, because or it can support any kind of ML use cases, but in this V0 we specifically want to focus on SageMaker training job task because it has a slightly different implementation under the hood. But basically, we want to support, we want to let the SageMaker training job being able to use this checkpointing mechanism so that you can schedule your SageMaker training job onto Spot instances. And here the interfaces we have and then we use checkpoint assist to actually persist that checkpoint onto the cloud. And we want this to be explicitly written by the user. And then when we come to V1, we think that because this functionality is apparently usable, I think it is very generic and it should be usable by all the different, like a lot of different type of Flyte tasks. So V1, the target, the goal of V1 is to execute this thing, to implement this thing in a generic way. So you can, like, even in Python task, in PyTorch task, in TensorFlow task, you can all use this checkpointing mechanism to checkpoint your data and resume from it resume from it later, so that you can jumpstart to your partial progress. Yeah, and so yeah, here's just another different another example of the user interface. And here you can see that it's a Python task, and we can get the checkpoint from the workflow parameters, which is the older version of this, which exists in this conventional version of Flyte. In the new Flyte, it will be inside a context or something like that. I haven't dig deep into that, but so yeah, and the usage is also very simple. You can write to all these this checkpoint locally by using the save function. And then once you are fine with taking a snapshot and uploading it to the cloud, you can call this persist, and that uploading will happen. Yeah, so that's pretty much it. Please, if you are interested in doing in this function, in this feature, please take a look at this document and please provide feedback. Thank you so much.
Thanks, Cheng-Hong. We're coming up on an hour, and I want to be sensitive to people's time, and so I think we're going to have to postpone one more agenda item, right?
No, I think we talked about it already.
Oh, we
Yeah.
talked. Great. Oh, good. Okay.
Yeah. Can you just share that doc, Cheng-Hong, maybe, or maybe George, I guess, in the meeting notes or something, so people can.
Sure. It can be accessible from the.
Right.
Yeah. Okay. Sure.
Yeah, just shoot me a link out, or Kate,
yeah.
we'll put it in the meeting notes.
Yeah. But yeah, awesome stuff.
George, should we take a quick poll about next time?
About what?
Whether or not we want the meeting, or Keithan.
Oh, next, yeah. There's the next meeting would normally fall like just right before New Year's and the week before New Year's. So we were thinking to take that time off, since many people are going to be traveling, at least in North America, or at least off that week. That's a sort of traditional off week in North America. Does anybody else want to drive the agenda without us, or should we just wait for 4 weeks from now? I guess I will take silence as assent that we should skip the December 20 whatever meeting and resume in January. Is that good? Okay, I'll take that as a good. So we'll send out meeting notes and video as soon as they're processed. And then a reminder that we won't be meeting next week, and we'll come back in. We'll probably change the Zoom link, so that'll go out in Slack and to users. But we're going to change to the paid plan of Zoom, so the meeting ID will change. So if you just click on the old one, you probably will be lonely. All right, everybody. Kate, you got anything else? Okay, everyone. Thanks very much.
Thank you.
And we'll see you in about a month.
Okay. Bye.
Bye-bye.
Bye.
Thank you. Bye.